let's begin creating our character's fireball projectile special attack. For this, we'll simply need an animation, some particles, and a 3D mesh for our projectile. In the link in the description, you'll find the link to freely download the assets and scripts or macro we created in this video. Feel free to download them and follow along, dissect the particle system, scripts, or macro, or to simply use the completed effect in your game or project. With both the effects from our energy and fireball complete, let's move on to creating the mechanics for our projectile. First, we'll need to create a spawn point on our character for the charging energy ball. So in our character's bones, let's create an empty game object to be a child of the character's right hand joint. With that complete, let's now begin creating our mechanics. We'll begin by creating a new empty game object, which we'll call Macro Manager. And then we'll create a bolt flow machine component and create a new macro for our fireball special attack. However, if you're following along from our melee combat attack and defense videos or our health system video, you can simply place the nodes in one of these macros. For the sake of this tutorial, we'll simply create a brand new macro. With the macro created, let's now open our editor graph and variable graph windows. We'll start by creating object graph variables for our character's animator, our energy ball prefab, our fireball prefab, and our energy ball spawn point. We can leave our character animator variable blank and simply set it in our start event. However, our character, energy ball, and fireball variables will all be game object variables, and our spawn point will be a transform variable. Let's set our character and our spawn point values with their respective objects in our scene, and set the energy ball and fireball values with their respective prefabs. Lastly, let's create a graph variable for both our energy ball and fireball, and these variables will simply house our energy ball and our fireball once they're spawned into our scene. With the variables created, let's start our graph by getting the animator component from our character game object variable and using that to set the value for our character animator variable. Before we begin creating the rest of our graph, let's first go over the logic that we want to create. When our player inputs the command or presses the button to launch our fireball, we want it to first trigger our special attack animation. Once our special attack animation is triggered, we want to then spawn or instantiate our energy ball prefab at the character spawn point. Once our character's animation is at the point where they seemingly launch the fireball, we want it to then destroy the current instantiated energy ball and then instantiate or spawn our fireball prefab. Once our fireball is spawned into our scene, we want it to then move the direction of our opponent, and if they're hit by or block our fireball, we want our instantiated fireball to then be destroyed. With that said, we'll start by using an on-keyboard input event, and we want to then create an animator set trigger node. For our target, we want to use our object graph character animator variable, and for the name, we'll simply place the name of the parameter that we created in our animator, which in our case is special01. We want to next create a component instantiate node, and we want to use the instantiate node that allows us to input a position, rotation, and a parent. The reason for this is we want to parent our energy ball with our spawn point, which will allow it to follow the movement of our character. For the input of our original, we want to use our object variable energy ball prefab, and we want to use our spawn point transform as the parent. We also want to use both the position and rotation from our spawn point transform variable as well. For this, we'll use a transform get position and transform get rotation node, and we'll place them as the inputs for the respective values. Lastly, we want to use the output of our instantiate node to set the value for our graph variable energy ball value. Before we continue, let's test out our functionality so far. We can see when we press play, our energy ball is instantiated into our scene, and our graph variable is set with that instantiated object. Additionally, our energy ball is also parented to our right hand spawn point and moves as our character's hands move. Next, we'll need to destroy our energy ball and then instantiate our fireball prefab. However, we want this to happen at the point of the animation in which the character appears to shoot out the fireball. So if we go and look at the animation in our project window, we can find the point in time in which the character seems to shoot out the fireball attack. So with that in mind, let's go back to our graph and add in the second part of our special attack. So let's begin by creating two float object graph variables, which we'll call charge time and fireball speed. Our charge time variable will represent the time the character starts the animation until the point in the animation that they appear to launch the fireball. From our animation clip, we can see that this happens just before the 1 second mark. So we'll set the value for our charge time to be 0.9. And we'll use our fireball speed variable to be able to increase or decrease the speed of our fireball. However, at this point, let's create a component destroy node. And for the input object we'll destroy, we'll use our energy ball graph value, and we'll use our charge time for our destroy delay. So if we now go back into play mode, we can see that our energy ball is now destroyed at the point the player appears to be launching their fireball in their animation. Next, let's create a custom event trigger, which we'll call launch fireball. And we'll then create a custom event by the same name. And let's start by making our custom event a coroutine and using a wait for seconds node. And for our delay, we want to use our charge time value, but we'll subtract it by 0.1, which will allow our fireball to spawn right before our energy ball is destroyed. And the reason we're using a wait for seconds node, despite the fact that we have a delay within our destroy node, is simply because that delay doesn't delay the flow of the graph. And it simply represents the delay before that particular component is destroyed. After our wait for seconds node, we want to then instantiate our fireball and set its position and rotation to the transform of our spawn transform variable. We want our instantiated object to then set the value of our graph fireball variable. At this point, we'll need to create a way in which our fireball can move towards our opponent. And we'll do this by using a vector 3 move towards node. In order to do this, we'll also need to create a few more variables. So let's create an object graph variable, which we'll call target transform, a graph boolean variable, which we'll call can move fireball, a float variable, which we'll call speed, and two graph vector 3 variables, which we'll call target location and fireball location. With all our variables created, let's set our target transform value with the target object from our scene. Next, we want to set the value for our can move fireball boolean to true right after our graph fireball variable is set. Next, we'll need to create an update event, followed by a branch node. For the condition of our branch, we want to use our canMoveFireball variable. If our branch is true, we want to then set our speed variable by adding our speed to itself plus delta time and multiplying that by our fireball speed. We next want to set our graph target location vector 3 variable with the current position of our target transform value. And we'll also need to set the fireball location by using the transform from our graph fireball variable. Once we set our fireball location variable, we can now use a vector 3 move towards node. For our input, we'll set the current location with our fireball location variable. We'll set the destination as our target location variable, and we'll use our speed variable and value for the max delta. And we then want to use this output to set the new position of our fireball. Lastly, we want to use a branch node, and for our condition, we're going to say if our target location is equal to our fireball location. Set our speed value to 0, and set our canMoveFireball boolean to false. We want it to then destroy our fireball. At this point, though our graph is complete, if we were to set our fireball speed and go into play mode and launch our fireball, we would see, despite the fact the fireball reaches the player within our graph, we can see that our branch node is still set to false. And if we look closer at our vector 3 graph variables for our target location and our fireball location, we can see that though the numbers appear close, there is a slight difference. So in order to prevent this, we'll need to remove our equal node and instead use a distance node and then output its value to a less or equal node. We'll place point 1 as our B value, then output the boolean into our branch node. At this point, the basic functionality for our fireball special attack is complete, and we can now add things such as our hit effect, add our special attack to our health script, as well as a knockdown or knockout animation.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, and free game asset giveaways.